So I said in a previous video that one of the things that's hard for students sometimes is to tell what math operation to do when. So we're going to go through some examples of distinguishing a multiplication problem from a division problem. So I said in that video that a multiplication problem is where you see the same number repeated over and over again, and what you're looking for is the total. And then a division problem is something where you have the total, you have a smaller number, and you want to know how many of those smaller numbers fit into that total. So let's go through a few of these. This one says Lee's Welding produced 193 base frames. Each frame required 98 spot welds. What's the total number of spot welds for the entire job? So if you think about this, here's these, we have 193 frames, and each of them has 98 spot welds, and we want the total. So that means if you think about, so frame number 1 has 98 spot welds, frame number 2 has a bunch of spot welds, 98, 98, 98. So there's lots of 98s because every one of those base frames has 98, and what we want is the total. And so that means that I'm going to do 193 times 98. So you notice I do a lot of sketching because I think visually, so I'd recommend that you do that too, or at least try it, see if it works for you. So here I'm thinking to myself, each one of those frames is 98 spot welds, and so that helps me visualize, oh, it's the same number, 98, over and over and over, 193 times. So that makes it a multiplication problem. This one says 39 rows of studs will be welded to a metal platform. Each row will be 5 inches apart. There'll be 27 studs in each row. What's the total number of studs required? Now notice this is one of those typical annoying math problems that has a piece of information you don't need. We aren't looking for how big does the thing need to be, so this 5 inches apart thing is just to distract you. So you have 39 rows of studs, and there'll be 27 studs in each row. So the way I think of that is I got my 27 studs, and then I got another 27 and another 27, and I keep doing that, and there's 39 of those. So that's that repeated number over and over. So that means that's a multiplication problem. Here's another problem that says a piece of angle iron 120 inches long is to be cut into 19-inch pieces. Assuming there's no loss of material due to cutting, how many 19-inch pieces would be obtained? So I'm going to do my sketch. I've got a 120-inch long piece, and I'm cutting it into 19-inch pieces, and I want to know how many of those would fit in this 120 inches. So that means this is a division problem. It's 120 divided by 19. So I'm trying to figure out how many 19 inchers will fit inside that 120 inch piece of angle iron. This one says how many inches of chrome plated tubing will be required to manufacture 289 of these tables. So here's the piece of information we have. We don't care about it being 1 by 1, but we do care that it's 23 inches of this square tubing for each leg. So think about that. You've got that leg is repeated 4 times. So you have 23, 23, 23, 23. So that's 4 times 23. And then that's to make one table, and that same number of inches of tubing will be needed 289 more times. So that number will be repeated over and over again. So I get an answer for that one, and then I take that number and multiply it by 289 to get my final answer. So again, repeated number over and over again. This one says, how many 17-inch pieces can be cut from the 16,761-inch roll of steel shown? So they're talking about these 17-inch wide things. So I'm going to sketch this again, and I go, well, that's 17, and then I got another 17, and the thing is, I know the total. I want to know how many of these will fit. So remember, when I'm looking for the number of them that will fit, it's going to be a division problem. If I knew how many of them I was going to use, and I wanted to know how much total steel would I need, that'd be a multiplication problem. But I know the total amount of steel I have. I know the small measurement, and I want to know how many of the small things will fit into the large thing. That makes it a division problem. So it's 16,761 divided by 17. And our last one here says, review the following diagram, calculate the weight of the weldment. Assume that there's no filler added to the welds. Okay, so here we have a 15-foot thing, and here it gives the size, which we don't need, but it's 45 pounds per foot. So the way I think of it is, you got 15 feet. Here I've got 45, 45. Each foot is 45 pounds, and I have 15 of those. So that's 45 repeated over and over again, and I know how many times I'm repeating it. So it's 45 times 15 to get that one. And then we're going to do the same thing on this one. This is 5 pounds per foot. So there's a 5, another 5, another 5, and on down, and we have 18 of those. So we have 18 times 5, and then I'm going to put those two together to get the entire weight of the thing. So remember, the idea here was just to try to get a sense, and sometimes it's hard to do this, so be patient with yourself, but you're trying to get a sense of when do you want to multiply and when do you want to divide. Of course, it gets a little harder when we get into fractions, because fractions kind of muddle up people's intuition. But hopefully this is helpful to get you started on that process.